All right, now we're looking at number 14 on this test. If 3x minus y equals 12, what is the value of x 8 to the x over 2y? So what this question is really wanting you to do, or really wanting you to know, is the law of exponents. So we have several different law of exponents, but the one that is very valuable to us in this question would be law of exponents when using division. So if I was to have just generic, just some value of a to the m over that same value of a to the n, I can now subtract my exponents. This is one of the rules of the exponents. If you have the same base, so if this was 2 to the 3 and 2 to the 4, this will end up becoming 2 to the 3 minus 4. Same base and division, subtract the exponents. There's different laws of exponents. If you're multiplying, you add the exponents. If it's your power, you multiply them. Different things like that. So in this case, the first thing we need to establish for this question is, how do we get 8 and 2 to have the same base? Well, what do you know about 8? Well, 8 is the same thing as what? 2 cubed, right? And I'll just put 2 to the y there. I haven't changed anything whatsoever. Again, another law of exponents here. We have a base to a power. What that allows us to do, so if I was to have a to power, that will allow me to multiply the exponents. So same thing here. This will be 2 to the 3 times x, which obviously is 3x. And then 2 to y is the same. What does our first law of exponents say? If you have a base to a power divided by a base to another power, we can just subtract the exponents. So we have this a base, 2 to a power, which is 3x, and another base, 2 to another power, y, and it's being divided. That will allow us to now write 2 to the subtract the exponents, 3x minus y. Now the question is asking, what is the value of 8 to the x over 2 to the y? Ideally, we're plugging in a number for x, plugging in a number for y, but here's a cool thing. We don't know what x is, we don't know what y is, but we know what 3x minus y is. That is 12. 2 to the 3x minus y now becomes 2 to the 12. Answer would be A. So this question was really harping on, hey, do you know your law of exponents? It focused on these two. Perfect. Look at number 15 now. If ax plus 2 times bx plus 7 equals 15x squared plus cx plus 14 for all values of x, and a plus b equals 8, what are two possible values for c? So looking at this equation here, what this essentially is saying here is, if I plug in some number for a and some other number for b, and I was to FOIL these two binomials out, do front, outside, inside, last, I would get this expression here. I would get 15x squared plus some number cx plus 14, which that makes sense. You know that when you FOIL things out, you usually get a quadratic expression. So now the question is saying, okay, well, if you do plug in a number a and you do plug in a number for b, what is that middle term? What is that c value? So let's just, before we do anything else, let's kind of get both things on the same term. So let's go ahead and FOIL this out. So remember, FOIL. Again, FOIL, so the F is either the first, the forward, the front. I'll just say first. O is the outside or the outer, whatever your teacher has told you. I is the inner or the inside. And L would be the last. What does that mean? Is I'm going to multiply my first two terms in my binomial, my outside two terms in my binomial, my inner two terms of my binomials, and my last two terms. So how does it look like practically? AX times BX, well, that'll be AB, and X times X will be X squared. So that was the first. Outside, AX times 7, well, that'll be just 7AX. And then 2 times BX, obviously just 2BX. And then finally, my last, 2 times 7. That would be 14. And then let me make some changes here real quick. I apologize for that. I just wanted to give myself some more room here, so I just erased the FOIL part and just slided this over to the left. Nothing too crazy. Okay, so remember what I said at the beginning. I was going to plug in some number for A and plug in some number for B, multiply this nonsense out, and I was supposed to get 15x squared plus cx plus 14. And it's starting to take place. You see the 14 here is the same. Something happens here with the A and B that when you add them, you get cx. And something happens here with the AB, when you multiply it, you get 15. So the question is, we want to find C. And there's a question saying there's two possible values of C. Okay, well, in order to find C, we'll need to find out what AB is first. Okay, so then looking at this, what information do we know about this quadratic expression? Well, we know something, when you multiply A and B, you better get 15. And then, let me switch colors here. When you do 7ax plus 2bx, you better get C. So how does that actually look like when I write it out? That means, let me switch colors here again. When I do A times B, I better get 15. And when I do 7a plus 2b, I better be able to combine my like terms and better get some value of C. So we can actually use this information and the information they give us to find out the values of A and B. Because what else do we know about A and B? Well, we know when you multiply it, it's 15, but when you add it, it's also 8. Again, I'm just going off of what the question was telling me here. So before we find C, we got to figure out what is A and what is B. So let's think of two numbers. Two numbers, when you add them together, you get 8, and when you multiply them together, you get 15. That should sound familiar, the method of finding it, because that's how you do factoring in general. You find two numbers, then when you multiply them together, you get the middle number, and then we add them, get the last number. So let's think about that for a second. If you need to pause the video, you can pause the video. I'm going to go ahead and write out the answer. What about 5 and 3? Let's say if A was 5, and let's say if B was 3. Does that make sense? Let's see. 5 plus 3 equals 8, and 5 times 3 is 15. But that kind of raises the question, why did I choose A as 5 and B as 3? Why can't I do it the other way? Well, you actually can as well. Let's say A was 3 and B was 5. You remember, multiplication is commutative. So A times B is the same thing as B times A. So if A was 3 and B was 5, you still get 15. Same thing if A was 3 and B was 5, you still get 8. That's also the reason why they're saying, hey, we're at two possible values for C, because there's two possible ways that A can be 5, A can be 3, and B can be 5 or B can be 3. So we found our two values for A and B. If A was 5, B would be 3. If A was 3, B would be 5. So let's actually plug them in and figure out what we actually get for C. So let's go with this first case here. So going to the first case. So 7. So in this first case, A is 5 and B is 3. So what do we get? We get 7 times 5, which is 35, and we get 2 times 3, which is 6. I'll go ahead and write it out here. And we'll end up getting 41. So in this case, C is 41. Now, if we wanted to, we could stop there, because that's our answer choice D. But if another answer choice had 41, we have to plug in our second option as well. So this is our second option here. So looking at our second option, that's saying when A is 3, they're saying B is 5. So what is that? So that's 21 plus 2 times 5 is 10. 31, which is C. And that fits our answer choice D. So yeah, this one you just gotta remember how to multiply two binomials and what it means when you actually factor. Okay, looking at this next question here, number 16. We're now entering our free response section, so we can't rely on our answer choices to help bail us out here. So, 16. If t is greater than 0 and t squared minus 4 equals 0, what is the value of t? Honestly, they just want you to solve for t here. So when they say that, isolate t. Get t by itself. Get your variable by itself. Get your variable on one side of the equation and everything else on the other side. So look at this. T squared minus 4 equals 0. Well, like I said, get your variable on one side, everything else on the other. So let's just add 4 to both sides. And we'll get t squared equals 4. Because 0 plus 4 is 4. So how do we get t by itself here? Technically, people are like, oh, it is by itself. But this is t times t. We want just one solo t here. How do you undo a square? Well, it's by a square root. Same thing for a cube. You do a cube root. Fourth root, so on and so forth. We take the square root of both sides. T will end up being plus or minus 2. And this question here, they give you the information that t is greater than 0, which will tell you that t will have to be the value of 2. I went ahead and included this plus or minus just so you remember that when you take the square root of a positive number, there is a positive answer and a negative answer. Because what does that actually say here? This is saying 2 squared is 4. But also says that negative 2 squared is 4, which is right. 2 times 2 is 4. Negative 2 times negative 2 is positive 4. But for this question, that was extra. If t is greater than 0, that means t has to be some positive number. That would give us that t would have to be 2.